How's it going, folks? Rosendo from MLH here. Yeah, that audio was. I just realized my Twitch stream also had the audio. That's why I was like echoing there. Rosendo from MLH here. Welcome, y'all. If you are excited about MongoDB Vector Search 101, please let me know in the chat. Just a couple of things that I do want to get out of the way before we jump right into everything that we are going to be covering today is that you should get registered for this workshop. So I'm going to go ahead and drop that link in chat there. It's also scrolling across the bottom of the screen, as you can see. Yeah, what's up, Mongo fam? Yeah. We've got Prezo Freud, we've got Trisby, looking excited. Let me know what part of the world you're joining from so I can add a little bit of extra context with regards to the folks that I am presenting to. I always like to know where they're joining from. And if you're curious about where I'm from, I am actually joining from New York City in a borough called Queens. And right now it's 11 a.m. where I'm from. So just getting the day started in the best way possible, which is by interacting with my fellow Global Hack Week folks. And we've got some folks from NYC. That's amazing. We've got some folks from Canada and India. Queens represent. Yes, indeed. Yes, indeed. We got folks from Pakistan as well. That's amazing. I just got to shout this one out. Yeah, we're out here. We're outside. And yeah, we've got Pizo Freud from Malaysia. That's amazing. All right. Well, you know what? I do want to get into everything today. So make sure you do check in and check out the link there. And also another thing that I do want to call out is you can still sign up for MongoDB Atlas. And it is just an amazing platform to utilize if you are using databases on a regular basis, or if you're just getting new to MongoDB, it's a great place to start just to kind of take a look at all of the features that are available. So without any further ado, let's jump into the workshop content. So once again, hi, my name is Rosendo Pilley. I work at MLH, I work in customer success, and today I'm going to be kind of walking you through one of my favorite database platforms to be used on a regular basis. And yeah, it's going to be some good stuff. So really, before we jump into that, I just do want to have like a high level conversation about what vector search is. So today we're going to be going from beginner to pro. It really depends on how you define pro. It's kind of a subjective term there, but you will definitely get a lot better at knowing what vector search is after this session because we're going to be explaining things. So when we talk about vector search or a search technique called vector search, it's just search that allows us to use the same language that you'd use to kind of describe your thoughts, emotions, and feelings. That's also known as natural language. So for more context for the folks at home, why you're learning about vector search, if you're starting to build generative AI applications, it's really important to get familiar with this particular technique of search because you're going to be using it pretty extensively as you're working. So here we're just going to cover the basics, but MongoDB definitely has a more in-depth learning experience that you can try out after this workshop if you want to dive deeper. I'll be sharing links throughout that you can use to kind of like access that information that I'm talking about, but it'll definitely be there. And there's going to be so many more resources available to you after the workshop if you want to dive deeper, which is one of the great things about MongoDB in general. The other thing I did want to talk about are that MongoDB skills badges. So I did talk about this on Friday during the MongoDB one-on-one workshop. There are MongoDB skill badges directly related to this workshop. So at the end of the workshop, you want to check them out. You can also check out the MongoDB challenges we have for Beginners Week. And those challenges that are linked there are going to basically walk you through redeeming your MongoDB skills challenges. And all you'll need to do to get the badge is just pay attention to this workshop, and then you can add, and then you could do a quick knowledge check by clicking into the MongoDB vector search challenge on our website, on the Global Hack Week website. And after that, the badge is yours. And you know, I'll have relevant links for you to use once again if you want to go that route. But why do you want to get these badges? They're just great because not only are you able to learn new skills as you're like, you know, actually going through the knowledge, you'll going through the knowledge check, you'll have the ability to then like understand whether or not you did like actually learn that information. And it also gives you a shareable achievement that you can like, you know, put on your resume. You can share it on LinkedIn. It's pretty cool. So definitely check it out. Let me just jump into the chat really quickly to see if anyone's asking any questions. And with every Atlas come Compass. Yes, MongoDB Compass is definitely another tool you could use in correlation with MongoDB Atlas. It's simply MongoDB Compass is simply a desktop application that you can use to sort of like visualize the data that you have in your database. You can see some of the queries at work, and I'll share the link with y'all here as well if you want to go and download MongoDB Compass. Pardon. And let's see here, MongoDB Compass. So check out that link if y'all are interested. Definitely download Atlas first and then download Compass. Well, you don't have to download Atlas, pardon. You could just sign up for Atlas and then you download MongoDB Compass. All right. So jumping right along back to the MongoDB Atlas link. Mind sharing the link to full Mongo badges as well. All right, so what you're going to want to do is you're going to want to go to ghw.mlh.io/challenges. And you're going to search for the MongoDB challenges that are there. And pardon me, because all right, unmuted. You didn't have to hear that. Didn't want to sneeze all in your ears. At any rate, yeah. So check out that link for the challenges for MongoDB, particularly for Beginners Week. Each of those challenges is going to include basically a readout for all of the skills badges that you can achieve. And for this workshop in particular, you'll be able to go in and claim the MongoDB Vector Search skills badge after this workshop. Excuse me. So without any further ado, let's jump into the agenda. Today, we're going to spend around 30 minutes talking through a bunch of different concepts. What we're going to talk about is vector search, how it works with MongoDB, and then we'll spend some time talking about tuning and optimizing your vector search queries. And then we're going to stop for some Q&A. But obviously, we'll stop and answer the questions that pop up during the workshop itself. And also, as I progress through the workshop content, I'm also going to be sharing a sample application that MongoDB has prepared that kind of illustrates some of the concepts that we're talking about. You can see them in real life, basically, or in real time, pardon. So as I mentioned before, there is additional content that you can engage with for this workshop in particular. If you wanted to go in and do, basically a live version of this workshop, you can navigate to the link that I placed here in the chat, and then also kind of scrolling down at the bottom, it's going to walk you through all of the concepts that we're basically going to be talking about today. You'll just hit Start Lab and then walk through the MongoDB Atlas and Dev Environment section of the lab to get set up, and then you'll be able to basically run your own live examples of vector search and some of the other concepts we'll be covering. So I've said vector search a ton of times already. I'm sure you're wondering what vector search is exactly. So before we jump into vector search, we're going to talk about its predecessor. So for the longest time, search experiences on websites have been powered by a technique called lexical search. So this technique focuses only on keywords. So given a user query, so a search query, in this case, it's going to be Greek philosophy, it will fetch the results that contain the keywords in that search. And it's going to basically have all of that information configured behind the scenes. So say you run an online bookstore and you use lexical search to power the search engine on your website. If you search Greek philosophy, as I mentioned, you might see results like these. And as you can see, all of these results have the words Greek philosophy literally contained in them. So it's a very literal search if you want to look at it that way. So lexical search is great when you know exactly what you're looking for, but here comes the limitations. What if you can't remember the exact title of a book or the correct spelling of an author, or maybe you only remember a small detail of the book that you're looking for, like the color of the book cover? This is where vector search comes in. So vector search retrieves results based on the intent or the meaning of your query rather than the keywords within your search. So say you now updated your website search experience to use vector search instead of lexical search. The same query as before, Greek philosophy, might even surface results that don't exactly contain the keywords Greek or philosophy, but are very much aligned in the theme. So as you can see here, the results coming back, you're going to have a book by Plato, doesn't have the words Greek or philosophy in it, but are clearly within the Greek philosophy category. And the other two examples here, basically the same thing, but as I mentioned before, they are categorized within that genre of literature. Another thing you could do with vector search is you could also search using phrases that describe a book. So, for example, fantasy novel about a boy in a school of magic, and you search that, and hopefully it'll return something like Harry Potter and maybe a few other suggestions along the theme. And as you can see here, that's exactly what's happening. Um, so we have one Harry Potter book, and then other books that sort of feature a boy in a school of magic as well. I would assume so, at least. Say you read the first Harry Potter book and you want to read the next ones in the series, and you want to check out more books that are kind of in a similar theme, you can even search based on the cover of the image of the book. So here, for example, we're uploading a PNG that has the first Harry Potter book on it, and it returns other items that have similar covers. And as you can see here, it's not all Harry Potter books, but this last one, Earthsea, is definitely in line with the same type of styles and the same type of themes that would be located in the Harry Potter book cover. And if you're wondering what that is, it's this one all the way on the left from our previous slide. So, just to recap the difference between lexical and vector search, lexical search focuses on retrieving results based on exact keyword matches, whereas vector search retrieves based on similarity, semantic similarity, or the similarity in the meaning or the intent of the query. You'd use lexical search when you are confident that your users are likely to search using common terms, and you'd use vector search when you're expecting ambiguous inputs or, like, less accurate inputs, or things that rely more on using intuition rather than exact mapping to things. So you might find matches based on the intent or the meaning with the vector search queries that they're inputting. So lexical search is typically your first pass at building a search experience. It's a lot simpler to implement, but if you want a more holistic search experience that goes beyond just text to include other modalities or other types of search queries like text, image, audio, or video, then you're going to go with vector search. All right. So let's take a look at the comment section here. Are we getting recordings for all of these lectures? Yes, you're going to check out the YouTube page. So I'll drop the link to the YouTube page here. So it's going to be youtube.com at Major League Hacking. And you'll check those out there. And very convenient for you to watch at double the speed, double the passion. Interesting. Yes. If you want to hear me jabbering on at a very high speed, definitely go 2x on the recorded content. All right. So since there aren't any additional questions here, we talked about vectors a lot because obviously the term vector search has the word vector in it, but what is a vector exactly? So we've prepared an example for you. And this requires you to have some context around what the store Home Depot is. So if you don't have a Home Depot store in your part of the world, say in India or Pakistan, I'm not sure if they have Home Depots in Malaysia either, but Home Depots are basically these big box stores that have tools and other gadgets and like things that basically contractors would use, like people in construction or people that build things with their hands. That's the type of store that we're talking about here. Essentially a big store with a lot of big bins and a lot of big items. So imagine you're walking around a Home Depot store. You're going to see items organized and located based on the aisle number and the bin number. So you can represent the location of these items as an array of aisle and bin. And this is essentially what a vector is. So for now, just think of vectors as an array of numbers used to represent a particular piece of information. So to get even deeper into that example, let's say you're looking for a hammer and the hammers are located, I don't know, in aisle 10 and bin 25. So the vector for the hammer would be 1025 in this case, and it would be represented by an array of numbers inside of your database. So for an item in Home Depot, a two-dimensional vector might suffice, but in software applications where we're dealing with a large amount of text, and maybe we're dealing with images, audio, and video as well, two-dimensional vectors just won't suffice to capture the distinguishing features of these types of information. And we're going to kind of dive into what the solution for that is on the next slide. Oh, wow. Home Depot is one of the top running biz in Malaysia. That's amazing to know. I had no idea. I will keep that in mind for future times that I run this workshop. So embeddings. Now that you've gotten an idea of what vector search is, let's see what makes searching based on meaning or modalities other than text possible. So we talked about embeddings in MongoDB 101. This is going to be a little bit different. The concept sort of stays the same. When we talked about it in MongoDB 101, embedding was a basically a technique that you would use to model your data within a specific collection or a document, and that was basically adding additional fields into an existing document in a MongoDB collection. But here we're talking about and it's essentially the same concept, but here we're talking about embeddings in a vector search context. So once again, embeddings are a numeric, multi-dimensional representation of a piece of information. This information can be anything. It could be text, it could be images, it could be audio, it could be video. So what's special about this array of numbers or vectors is that they capture the semantic qualities of your data, essentially characteristics of data that capture the meaning or the essence of it. So this is very much flies in the face of lexical search concept, where you have to match an exact word to an exact phrase that is contained within one of your documents. In vector search, you can basically have an implied meaning, and those implied meanings are represented by embeddings. So this way, if you were to plot your data in this higher dimensional space, in the vector space, semantically similar data or data with similar meaning, they end up a lot closer to one another. So in this case, we have dog, cat, and then we have apples and oranges. So based on the embeddings that we have in our database, dogs and cats are less semantically close to one another or less semantically similar than an apple or an orange. Obviously, dogs and cats are both animals, whereas apples and oranges are both fruits. But according to the way that the data has been embedded in our example, apples and oranges are semantically closer to one another than dogs and cats. So the next question you may have is, how do you go from a piece of text or an image or audio to an array of numbers? How do we get that embedding into our data? So this is done by specialized ML models that have been trained to convert a piece of information to these numerical encodings or arrays of numbers. There are specialized models for different modalities. And when I say modalities, I just mean like, different types of data, like text, audio, image, video, which is where the term multimodal comes from. So multimodal models that can translate different modalities into the same semantic space. So in the lab I linked earlier, you can experiment with a multimodal embedding model that can take both images and text as input and map them to the same vector space. Let's see if we have any questions. We're kind of in the same spot as before. All right. And as I mentioned before, I will have a ton of different resources that I'm sharing throughout the workshop here. And here is just an example of multimodal or just embedding models in general that you can deep dive into. There are so many embedding models out there, and the choice really depends on what your data is and what you want your application to do. So here linked, and you could also use the QR code, there is a very detailed tutorial on how you can choose your embedding model, and you can check that out later as you sort of learn more about how to implement those embedding models into your own applications. Okay. So to perform vector search on your data, you first need to generate embeddings for the thing you want to search on. That's where the embedding models come from. So here we are searching for books. And in our books document that looks like the one on the left, we have several options. We can search based on title, we can search the synopsis, or with vector search, even the cover image of the book if we can find an embedding model that embeds images. So adding embeddings to data in MongoDB is very easy. All you need to do is add an additional embedding field to your existing documents, and it's as simple as that. So here, as you can see all the way at the bottom on the right-hand side of that same original document, we have added an embedding array. So arrays are a native data type in MongoDB, which means embedding vectors can coexist with the rest of your data in the same document in the same MongoDB collection. So you'll see how to do this hands-on if you go through the lab I linked earlier. And basically, yeah, I'd like to show you an example of how this sort of looks in person. So let's actually jump back to the original slide, just so you remember. This is the on the left side is the original document, and then on the right side, if you wanted to vectorize your database and basically add embeddings through an embedding model, you would simply add that array at the bottom, and that would represent the vector that that data lives in. So jumping into our live example, So this is Geo AI Search. This is an application that the MongoDB team has actually prepared for me, and I'm going to drop the link to it so you can check it out on your own at home. You could watch me do it as well. But essentially, this is a vector restaurant planner. You can use any type, you could use a vector search here to figure out what type of dinner you're looking for. You could also toggle the location. These are locations within Manhattan in New York City. And then you could also toggle the amount of meters or the radius from those locations that you would like to search. So let's say I want to search in west side of Manhattan, 1,820 meters radius in that particular region, that geolocation, and I want to look for a dinner. I want to look for hamburgers. All right, and then let's get restaurants. So it's searching the data, and all right, data is searched. So for top hamburgers, consider the following. So as you can see here, hamburgers, it's returning Shake Shack, which is a hamburger restaurant, it's a burger restaurant, it's a fast food place, and then we have In-N-Out Burger, which is it contains the word burger. This is like very simple in terms of the way that you would use vector search. This is more akin to actually a lexical search, even though it is utilizing vector qualities. So for a third option, they consider Five Guys, which is obviously a different type of burger spot. But yes, obviously these are all located within that set amount of meters to the location. And if you wanted to look at the vector search query, you could actually see it at the bottom here. So if you're trying this out at home, you'll see where the vectors are coming in from and how that's actually being fed into your query and how it's aggregating some of this information, as well as the geolocation, which is taking a little time, but it's a little less relevant to our current workshop. So I'm gonna go ahead. So this kind of takes a little, this doesn't take as long. I'm going to go back down to 500. And instead of searching just hamburgers, I'm going to try a more complex search. So I'm going to say, I have a big group of people coming to dinner, and they all have very different dietary restrictions. Can you recommend a couple of restaurants? All right. And let's see what happens. So let's get restaurants. It's searching the data. It has searched the data and it is giving me these options. All right. So the first one is Cheesecake Factory. It's known for its extensive menu. It's got a bunch of different things: vegetarian, vegan, gluten-free, and low-calorie options. So that's definitely in line with what I'm looking for. Yeah, I know there's no In-N-Out in NYC. I think I toggled the meters to be way too long because I have no real concept of what meters are because I am American. But yeah, we know there's no In-N-Out in NYC. I think it was maybe like a hallucination on the back end of the application. But jumping back to this, we've got True Food Kitchen, which also has vegan, vegetarian, gluten-free, a lot of different things that would be basically, applicable to other people's dietary restrictions. And while I didn't say specifically vegan, vegetarian, gluten-free, or low calorie for that matter, the search is definitely bringing this stuff up. And the reason for that is because we are using vector search to sort of allow the application to figure out what the intent or the meaning is behind our words. And if we wanted to kind of jump in and take a look at how some of this code looks like on the back end, and I'm jumping a little bit ahead here, but essentially I do want to show you where the embedding model is coming from. And here, you'll have access to this as well through the link that I sent out. But if you want to look at where the embedding model is coming from, this application is using a text embedding 3 small model from OpenAI. And this is how it's basically spinning it up. And then here in the vector query, this is how you're actually embedding vectors into your search query. What it's doing is it is taking the index, creating the query vector and the path, and then the num candidates here are going to be basically the number of different aspects that it's going to take you through. And then here it's going to limit that to 3. And then the filter, obviously, we're going to talk about that a little bit later. It's the new trip. So yeah, basically this is how your vector, your query is vectorized, and then it's fed to to the application, it returns something, and then whatever the information it returns is actually fed into an NLP to generate some sort of like response from the application in like human readable like form. So all that stuff, like the return data, is basically what the generative AI part of it is, and that's sort of like doing it in a RAG format. If you've never heard of RAG, you can look it up after this, but essentially it's like another form of retrieving data from a multimodal database or model. And here, obviously, you can see like some additional information. This is kind of like breaking down into like the front end part of the application because it's using Streamlit. But if you want to check that out on your own, definitely feel free to do so. Play around with like feeding this different types of information, and hopefully the map loads up for you a little bit faster. I think I may just be having bandwidth issues, but yeah, jumping back into our regularly scheduled program. Now that we've seen the live application, let's just recap what we've learned so far. So the first thing is that embeddings are an array of numbers that capture semantic qualities of data. The second thing is that embeddings are generated by specialized ML models. And then embeddings can be added in place into existing MongoDB documents, which is the entire concept behind embeddings in the first place. So let's dive a little bit deeper into vector search. Once again, if you have any questions, feel free to add them in the chat. Don't hesitate to interrupt me as I'm going through some of this content here. I am very much paying attention to the chat. So now that you know what embeddings are and how to generate them, let's see how they fit into vector search. Remember that embeddings map data that is similar in meaning and close to each other in the vector space. You remember the example with the cat and the dog, the orange and the apple. So given a user query, in order to retrieve results using vector search, you'd first generate an embedding for the query using the same embedding model that you used to embed the rest of your data. And then you would retrieve the items closest to the user query embedding in vector space. So as I briefly showed you earlier, you're not only placing embeddings into the data that is already inside of your database, but you are also placing embeddings onto your vector search so that the application can then go in and determine which vector that your search is closest to. And yeah, I know it's a little bit complicated, but we're going to continue to dive into it, and so hopefully illuminate the information that I'm trying to give you now. So this way you're basically using embeddings or vector search, enabling the search based on context and meaning from the user's perspective by also including embeddings into that original search query, if that makes any sense. Hopefully this next slide will help to explain that a little bit more. Without going too deeply into it, we're going to talk about how vector search works in MongoDB specifically. So in MongoDB, there is an algorithm. It's called Hierarchical Navigable Small Worlds, or HNSW for short. The way this works is by creating a layered connected graph where embedding vectors are nodes, and each node is then connected to a specific number of nodes or nearest neighbor based on their distance in a vector space. So as you can see here, at each layer, you have an entry point. And just for your context at home, the first layer is the top layer. So the top layer, and then it progresses down to the bottom. So at each layer, you have an entry point, and you move from one node to another. And in that layer, until you can't get any closer to the query vector in that layer, you're going to move on to the next one and repeat the process until you reach the final layer of your search. You'll also notice that the connections start off like pretty sparse. Like, so at the top, you're doing a more coarse search. And what that's doing is it's kind of eliminating a lot of different like possibilities to amplify the basically performance of your query. And so basically, as you narrow everything down to a general region where the query vector lies, once you get to the bottommost layers, it just sort of gives you the closest neighbors so that you can have the most accurate response possible. So that is how MongoDB vector search works. If you want to dive into this a little bit deeper, into hierarchical navigable small worlds, say that 5 times fast, you can check out the link that's up above. You could also check out the link that is right now added to the chat, and you could also check out the link that is now scrolling across the bottom of the screen. Um, this is a really interesting part of vector search, in my opinion, how the actual how the actual search goes through a ton of information in a 3D space, and then just basically gets you the closest possible result of what you're looking for. So the goal of vector search is to retrieve documents based on their proximity to the query vector in vector space. But in 100 or even 1,000 dimensional space, what does proximity or distance even mean? So you can imagine, like, a cube where there are different types of data that you're looking for, and all of that data is located into specific like portions of that cube. How do you even measure the space between your vector search and the vector that you're looking for? So it's basically calculated using mathematical functions on the back end. And with MongoDB, there are three different options. And the first one is Euclidean distance, which just measures the absolute or the straight line distance between the two vectors. Here, once again, the dog and the cat example come up. And here you would just measure what that actual distance is mathematically between those two vector points, and then you would come up with your vector distance or the proximity of your search to either one of these items. Then we have the dot product that multiplies two or more vectors to measure alignment between them. And the thing to note here is that with the larger numbers in the vector, they do have a slightly, I guess, skewing impact on your actual distance, because they multiply the values together. So here, obviously, the first location or the first coordinate turns into 12 because you're multiplying 4 by 3, and so on and so forth. And the last one, finally, we have cosine similarity, which looks at the angle between the vectors. So previously we saw that dog and cat have similar attributes or are semantically similar. The Euclidean difference between the dot product the Euclidean distance or the dot product between the vectors was quite high. But here, if we used either of these, the distance metrics for the vector search, you might not retrieve what you're looking for when you search cat or dog. So this is where cosine similarity helps, because it basically measures the angle between the vectors, which is always going to be a smaller number. So this is why we see cosine being a popular distance metric for vector search in general. Any questions? Looks like we are good to go. Let's proceed into the recap. So just once again, to recap what we've learned so far, vector search retrieves documents closest to the query embedding in vector space. We use the same embedding model to embed the data that you want to search on and the user queries. The distance in vector space is calculated using mathematical functions. And cosine similarity works well with most embedding models, because it's measuring that, once again, the angle of the distance between those 2 points. So vector search in MongoDB. Now that you understand how vector search works in MongoDB, let's look at how to perform vector search queries on your data in MongoDB. So here are the 3 steps. The first one is you're going to generate the embeddings. The second one is you're going to create a vector search index. And then the last one is you're going to send a vector search query. So we've already talked about generating embeddings. Let's talk about vector search index and how to create one. The next thing you need to do, obviously, here is perform a vector search in order to perform a vector search in MongoDB is create a vector search index to efficiently query your vector data. So the index specifies the path to the embedding field in your documents, the number of dimensions in your embedding, this also, and as well as the number of dimensions in your embedding vector. And this depends on the embedding model you use to generate embeddings, and a similarity metric specifying how to measure that distance in vector space. So in this case, it's going to be the type is the vector, the path is the embedding, the number of dimensions you're going to have, as we talked about before, is going to be 512. And then the similarity you're going to be using here is the cosine similarity versus the Euclidean or the dot product. And finally, this is how you would perform a vector search query in MongoDB. So vector search is part of MongoDB's aggregation framework. The aggregation pipelines are nothing but a series of data processing steps. We talked about aggregation pipelines before, and it's exactly what I'm saying here. It's basically a way for you to go into your database and basically I don't know, perform calculations on the data that are inside of your database and then come up with a specific result. So the vector search query always needs to be in the first stage in the pipeline and can be followed by other stages to further process the vector search results. Here, the application here, the example of the vector search query obviously has the vector search index, it has the embedding, it has your query vector, which, as I mentioned before, based on the embedding model that you use, gets assigned to your query. So this is where your query lives inside of, like, the entire vector space. The num candidates here are num candidates is basically a parameter in the MongoDB Atlas vector search stage, and that specifies the number of similar documents the vector search algorithm is going to check before it returns the final results. So here, obviously, the larger this num candidates number is, the longer your search will take, but maybe the more accurate it'll be. And the smaller it is, the looser the vector search is going to be, and the faster the search will probably run for. And limit, obviously, you're just limiting it to 10 different responses that are returned. The $ project stage that follows, it only returns the title field from the documents that you retrieve, along with the similarity score returned from the vector search itself. So in case you're wondering what all of this is just a query that you would be using inside of a vector search, and you could embed this into your application using whatever framework or language that you're using to build your application. As I mentioned on Friday, there are a ton of different SDKs that you can use in order to leverage MongoDB from a programmatic space. So there's JavaScript, Python, C++, Java. So definitely take a look at that. So now that we've kind of done this, let's go ahead and jump back into our live example. And I'm only going to do this very quickly because we kind of went over this earlier. But as we mentioned before, this is the vector search query that we have inside of this application that is actually returning those 3 results about the restaurants that you're looking for within specific places. So here, the vector search, once again, is just reading out like 10 different documents and searching through it. It's returning 3 different things. And then the filter that you're adding to it is going to be search trip, new trip. And obviously the response data coming in from the text embedding, like the response data is all being embedded using this specific OpenAI embedding model. Alrighty. So you saw how easy it is for vectors to coexist with the rest of your data in MongoDB. Effectively, MongoDB Atlas Vector Search provides you with an integrated platform for your operational as well as your vector data, but both queryable via the same API. Pardon me, I'm like sneezing again. Excuse me. Both queryable using the same MongoDB query API. So it's really easy to have both vector searchable data as well as just standard data inside of your same database if you're using MongoDB, which is very useful. Since your operational and vector data reside in the same collection, your data is automatically synchronized with vector indexes that you create on the collection. It's a fully managed service, so you don't need to worry about maintaining any infrastructure. You can just focus on building cool things instead. And finally, there are search nodes that can scale your vector search workloads independent of your operational workloads. So if you take a look at the slide here, you have the MongoDB query API that then goes into MongoDB Atlas Vector Search and then goes into your MongoDB Atlas Vector Store. So just to recap here, once again, to perform vector search in MongoDB, you need to generate embeddings, create a vector search index, and send a query. Then the number of dimensions in the vector search index depends on the embedding model that you used. And then the vector search should always be the first stage in a vector search aggregation pipeline. Pretty simple. All right. So looking at the questions here, Piso Freud, is there any bring your own cloud hosting for MongoDB as drop-in replacement to Atlas? And if yes, would Compass still work if you're using bring your own cloud? There are actually different clouds that you can use in MongoDB Atlas. If you check it out and you spin up an instance on your own, you'll be able to choose between, like the main providers, essentially like Amazon and like AWS and Google Cloud. There should be other options in there as well, and also different locations and regions that you can spin up your server from. You will need to do that in order to utilize some of the cloud aspects of MongoDB Atlas. And your yes, Compass will still work. You do need to set a connection URI within Compass that is connected to the database that you're using in MongoDB Atlas. So yes, in short, yes, it will all work. And I'm gonna see you again. So sorry about that. I think I'm just like having this all of a sudden like a surge of allergies that are just like popping in for no reason. All right. Um, Now that we've got that answered, let's go ahead and check out how we optimize the vector search queries that we're working with. Excuse me. Cool. So now that you've seen how to perform vector search on a small data set, um, most real world scenarios are you're going to be working with larger data sets, so there are going to be constraints such as cost, latency to worry about. So let's talk about some techniques to optimize your vector search queries, and the first one is going to be pre-filtering. And pre-filtering is exactly what it sounds like. In many cases, we see folks wanting to filter the vector search results based on certain logic that you have within your application. In MongoDB, you can do this by applying these conditions as pre-filters for vector search. So essentially, you first apply the filters to your collection to produce a filtered set of documents. If the number of filtered documents is less than the number of vectors or results to be returned, an exact nearest neighbor search is performed, and this can be slow. But if the number of filtered documents is more than the number of documents to be returned, an approximate nearest neighbors an approximate nearest neighbor search is performed. And when the HNSW, or the hierarchical navigable small worlds graph, is traversed, it only considers document IDs that are present within the filtered set. Essentially, it's just breaking everything. It's taking all of the data that you would have searched and creating a smaller data set to run the vector search on in order to optimize your data. So in many cases, sorry about that. I don't know why. And yeah, sorry, I should have been scrolling through these. My apologies. So in most cases, as long as your filters are not too restrictive, or in other words, as long as approximate nearest neighbor search is performed, pre-filtering actually helps with the vector search latency while also improving the accuracy of your search. So here you can see the star, the asterisk, is your original is the original search. This vector search dot is the standard unfiltered vector search, and then the filtered vector search is actually a lot closer in proximity to the query. So you might be asking, why pre-filter and not post-filter your search results? Well, to answer that, let's look at this example where we have a query vector and its vector similarity to documents in the books database we've been referencing. Now, let's say someone has indicated that they only want books that have less than 100 pages. If we apply this pre-filter and K is set to 2, uh, to only retrieve the top 2 candidates from the vector search, then the vector search will exit as soon as it finds these 2 candidates. But if we apply this as a post filter, we still end up doing the full search and grab these 2 documents with similarity scores of 0.95, of 0.95 and 0.92, only for the filter to drop the results. So with post filtering, you don't really get any performance gains while also running the risk of no results being returned from the search. So yeah, like pre-filtering is always going to be the best way to go. So if were thinking about that, then that is the answer. I would always suggest to pre-filter rather than to post-filter. Adding pre-filters to vector search involves 2 things. First, it's updating the vector search index definition to include the filter fields. So here you'll see type is filter and the path is pages. And yeah, like you're essentially just like adding it as another like item within your document. The other change is in the vector search stage of the aggregation pipeline. So you'd simply include a filter field containing the pre-filter expression. And in this example, excuse me. Oh my God. I almost sneezed again. In this example, we have the filter set to pages of 200 or less. So as you can see here, it's already kind of like highlighted on the slide itself. So just to recap what we've learned so far, Use pre-filters to filter vector search and results based on certain criteria. Then you're going to do a pre-filtering, which can slow down the vector search if the filters are too restrictive. And post-filtering is really not recommended at all. So if you want to dive deeper into this, there is going to be a link here. I'm going to drop it in the chat for y'all as well, mdb.link/AI learning-hub. Check out this link. It's going to be basically like, the best way to go in and sort of learn more about all of the concepts that we have been covering. And you could do so after this presentation is done. So really, that's it. I mean, the other thing that I would say here is if you want to go in and retrieve your skills badge, we can actually walk through that a little bit as well. Let me just go ahead and pull up a new browser. Let me show you how to do it. We're going to go into ghw.mlh.io/challenges. And you're going to see here that, we have a ton of different challenges that are currently featured. The first one is going to be the basic student skills badge. If you have not done this one yet, it's basically covered by the original presentation that we had. So that was MongoDB 101. If you went through that entire presentation with me on Friday, this is going to be something that comes fairly simple to you, and you could just go into the into the link that's provided within the actual challenges on the Global Hack Week page, and retrieve that information yourself. And here, obviously, you can now earn the badge. So you just register, and you can also check out other courses if you'd like. So here, you'd obviously sign in using the MongoDB Atlas account that you used. So you could sign in using that as well. And then you can go in and you can actually search all of the different types of learning paths that you can take, Gen AI apps, deploying and evaluating Gen AI apps. But for this one in particular, there is a vector search badge that I do want to show you. And it's going to be part of the MongoDB challenges page as well. And let's just filter down to partner and no code. And let's see here. And then let's search for the ones that says MongoDB. So claim your RAG with MongoDB skills badge, claim your CRUD operations with MongoDB skills badge, and here claim your vector search fundamental skills badge. And this is definitely going to be something that you'll be able to do after going through some of the additional learning materials that I provided in the workshop, and also after you go in and kind of like, check out the actual skills badge itself. With each skills badge, there's going to be material that you want to go through if you still don't feel super confident in jumping right into the skills check. So here, obviously, there's a video you could watch. Embeddings are going to be covered, performing an actual vector search. And these are all like, this is all video documentation that you could look at. So it's pretty simple to get through if you'd like to. I think someone mentioned earlier, you could just 2x the speed of the videos so that you're learning with twice the speed and twice the passion. I liked how that was worded earlier. And once you go through all this stuff, you're going to be able to go in and actually get into the skills check. It's not going to let me click into it because I don't think I'm signed in yet. But yeah, you'll be able to search this MongoDB skills badge and just get through all of this information. And yeah, it's pretty simple. So once you get in here, you'll be able to get into the skills check and see there's only 10 questions that you need to answer. So it's really not that in depth, but at the end of the day, it will still be pretty useful for the folks at home that want to participate. All right. We are coming in to the Q&A portion of our workshop. So if you have any questions about MongoDB, vector search, or even stuff from MongoDB 101, I'm happy to kind of walk you through any of the questions, or maybe even guide you to finding the answers yourself. So if you have any questions, please drop them in chat now. Otherwise, I will kill some time by doing some additional I guess stuff here on this example application. I could also show you other applications and kind of point to maybe some of the other concepts that we've learned thus far. Okay. So here, once again, let's just try something here. So Times Square, 500, and I'm going to look for, can you find me restaurants where none of the food is made with gluten. Let's see. Let's get restaurants. These are going to be 500 meters within the proximity of Times Square. So we got niche gluten-free dining. Everything is gluten-free. And then we have harvest table, all of this stuff, farm to table concept with entirely gluten-free options. So as you can see here, and it's funny because it gives us the top two results, but it doesn't return like the full readout on the third result. And that's, obviously part of how the UI is structured in this case. But if you wanted to take a look at the vector search, you can see here the query vector is broken. This is like all of the embedding, the vectorized portion of that search based off of, the text that I actually input into it. So you can see it's pretty extensive, and the application is doing that on the fly. It's embedding your actual vector. It's embedding vectors into your actual search query, which is something I find like extremely fascinating because that in and of itself is probably a huge undertaking. And as you can see, I'm still scrolling through all of these like coordinates here, all these locations within the vector space. And then once you get to the end of it, you got the path, the num candidates, the filter, and then the search trip. And obviously it creates its own object ID, which was not hard coded into the previous code sample that I kind of looked at earlier. And it looks like we have some folks jumping into the chat here. In MongoDB 101, we covered embeddings as one to few document object model. And the embeddings in vector search seem kind of sort of similar, but not alike. How to differentiate between the two. So the way I would say it is this: embedding in MongoDB 101, embedding is it's a technique that you can use to model your data. So the term embedding in MongoDB is simply adding additional data into an existing document. And it's after the document has already existed, you're just going to go in and add additional data to that JSON object. So I think one of the examples last time was we had an employee use an employee object inside of our database, or an employee document. The guy's name was John Doe. And if you wanted to add the address to that document at a later point in time, you would use embedding. And then the other technique for data modeling that we talked about was referencing. So instead of embedding the exact address into that document, you could also include a reference to the address that is listed in another collection potentially, and basically just like have another document referencing the address being referenced inside of the original document. So it's like embedding versus referencing. Which one is good? Which one is bad? Where do you use it? What are the typical use cases? Here, embeddings in a vector search context are actual like coordinates that you will also, and confusingly enough, embed into existing documents within your collection, and they are supplied by it's a machine learning embedding like that is pre-made for you, where basically someone has gone in and created this model that has like all of this data with pre-specified vectors inside of it, and vector coordinates inside of it. And what that does is it'll take the data that you have inside of your database and basically match it up with those things, and then include those embeddings within your actual document. So that's kind of like the difference. Let me know if that helps. And here, could you send the link of the MLH page with the badges? We can get to it, please. Yes. Oh, it looks like most folks have, well, they've shared something. This is the one that I would reference here. It's going to be ghw.mlh.io/challenges. And if you need any of the other information, once again, you're going to download MongoDB Atlas using this link here that's scrolling on the bottom. And you can then download MongoDB Compass somewhere. Here, I'll just write it in. You could download MongoDB Compass here, VHW, MongoDB Compass. And you could do that here. All right. So, Pizzo, did that answer your question? I hope it did. They are different, but the same. Like, so basically, when you're embedding like vector search or into your documents, or you're embedding those vector coordinates into your documents, you're not only using an existing embedding model, but you're also actually embedding data into your documents. So it's like it's a little bit different, but it's all also like very similar at the same time, which is can be a bit confusing. All right, love to hear it. Okay. We had a little bit more time, but if there are no other questions, that's essentially the part of it. The map didn't load up, unfortunately. But once again, if you want to access this application, you can do so yourself. I'll go ahead and post it again. It's a pretty interesting application if you want to look at it and you kind of want to like check out some of the other applications that MongoDB has provided for us today, for some of these app demos. Pardon, sorry. There you go. Why am I having such a hard time typing? There you go. This one is called Mongo Story, and it's basically a pretty cool application that you can use to see how. Let me hide this stuff. You can use this application to kind of see how you would input data into a database in real time. It also uses generative AI features as well, so you can go in, just sign in. You could use anything you want. You could use a fake email if you want. You don't need to use your real email, but essentially, you can go in, check it out, get logged in, and then you can auto generate your own blog like information if you'd like, and you can see how it kind of like links up with other parts of your like you can actually check out the queries or the data that's being transmitted back and forth if you click on some of the other portions of the application itself. And then we have the Mongo MP player. So this is like a Mongo Spotify example, and y'all could check that out as well. I'll drop the link in chat. And as this loads up, you'll see this is kind of the same thing. You can go in and check out how some of this data is being aggregated. So this is the search function. Then there are the new releases function. This is how you're this is how it would look from a MongoDB perspective. And you got to click it twice in order to get that out of the way. And then let's see, what else can I show you? I mean, yeah, this is just like it just continues to show different songs. You could add playlists, and you'll see how these playlists are sort of when they were created and how you actually play the music. And then you could also jump into artists. And I'm just gonna go ahead and click out of this because that is kind of loud. But yeah, that's it. I really want to thank everyone for joining today. Once again, make sure you go in and try to claim those skills badges. I apologize if I was a little congested on the call. I am coming up with a random bout of allergies today, but outside of that, I hope I was able to help y'all with like learning more about MongoDB and learning about vector search if it's your first time learning about vector search. It's a really interesting topic. There are a ton of different resources that you can dive into in order to sort of expand your knowledge and your expertise on that topic as well. Thank you all so much. Trisby, Queens represent. Donut Guitar, two of my favorite things in the world. We've got AnFam as well saying thank you. Must have been the pollen from Queens. Yes, maybe. There are a lot of trees out here on my street, so that could have been an issue. But yeah, outside of that, I'll go ahead and sign off for today. Once again, it's Rosendo from MLH. Please stick around because we do have today in Global Hack Week coming up in just about a minute here. So you'll be joined by two other folks from the MLH team that are going to be walking you through what else is happening for day 4. So yeah, until next time, I will probably see y'all again tomorrow at 12 p.m. Eastern. So if you want to check out the Global Hack Week Daily that's coming up today and tomorrow, I will be on the one for tomorrow. All right, y'all. It was been real, and love chatting with y'all and hanging out. Have a good one.